definitely need your formula sheet, that SOL purple sheet out on your desk, okay? I want you to be able to identify the set of formulas that we're going to be using to find lateral area or surface area or even volume. So when I ask you to write this example down in your notes, do the best picture you can. And I understand, I can't draw that well either. But just try your best. What shape is this guy, by the way? What shape is this? Pentagonal pyramid, okay? I like that. Really only need to copy this first two sets of directions, maybe, the information down in the picture, okay? So I'll give you a second to copy that down, and then we'll talk about how do I find the lateral area, and that's what we're going to find, the lateral area, okay? All right. So what I want us to do, once you've copied the problem down, I want you to look at your formula sheet, and I want you to identify the formula that we need. So look on your, find the pyramid formulas. So what, say it again, sweetie. It's not length. What does that L stand for? Slant height. So it's 1/2 slant height times the perimeter of the base. Make sure we really understand that that little cursive L doesn't mean length. It does mean slant height, okay? So let's read the problem and figure out if we have anything that we need. When I read the first sentence, what are some things that are helpful? The perimeter. Do I need the perimeter in my formula? So let's plug it in. What number am I going to plug in there? Great. Leave a blank for that, and then I'm going to plug in the 60. All right, let's keep reading. Regular is important. Regular means what again? If it's regular, always 360 on the outside. Regular means all the sides are the same, right? And all the angles are the same. All right, so we're still trying to find the slant height. Let's see if the next sentence will help us. So the next sentence says its slant height, good, is 3 times the length of one side of the base. Well, it doesn't give me a number. How'd you get that then? You're right. Perfect. So if I divide the perimeter, 60, by the number of sides, so 60 divided by 5, and what'd you get for that? I got 12. Right? So 12 is one of the sides. Do you agree? But where the 36 came from, you just jumped ahead, was to do what? Multiplied it by 3, because it's 3 times that, right? So our slant height, our L, is 3 times the length of one of those sides. So the slant height is actually 36. How do we feel? Lost? Where'd I lose you? Five is the number of sides, exactly. So the slant height came from the blue sentence. 3 times, but we had to find one of the sides first. And so Ben said to find one of the sides, I don't know, I'll highlight it in pink. To find one of the sides, that's where the 12 came from. Okay? What number did you get? Kind of a big number, I think. Did you get 1080? Yeah. Or 1080? What units am I going to be using? Not cubic, because this is lateral area. Area still squared. So what are, it's feet, right? So this is square feet. Remember what lateral area represents. If we have the pyramid that I have here, isn't it just the clear triangular faces, right? Those triangles? That's your lateral area. What if I said I want you to find the surface area too? So let's do that. let's find the surface area of the same picture. So you have the picture drawn on your paper. It's that pyramid, that pentagonal pyramid. What's the formula for the surface area of a pyramid? Look at your formula sheet. What does it say? Hopefully it says this. What is that? Well, it's the lateral area that we just found plus the area of the base. That's what that says. So we just found the lateral area. So the only thing we need to find now is the area of the base. So I think I mentioned it to a couple of you when you were in your groups. The area of the base is sometimes and actually almost always, an entirely separate calculation. What shape in our case, in this example, is the base? What shape was it? Pentagon. So I'm going to go ahead and grab and draw a pentagon for us. You want to do this on the side. Go ahead and you do that too. You want to find the area of this pentagon. In our pyramid, what information did we have on our picture that was labeled? We had that the bottom had a side of 12. So let's label that on our pyramid as well. I'm sorry, our pentagon as well. So I need to find the area of this. Think back to what we did last class. How did I find the area of a regular pentagon? What did I have to do with? There's no formula for it. What did I do? I had to divide it up into things. I divided it up into triangles. And I just drew all the radiuses. Do you remember that? So I draw all the radiuses. And I want to find how many of those triangles do you see? How many of these triangles are there? 5 of them. So when I want to find the area of the base, I have to have 5 triangles. 5 1/2 base times heights. This is what we did on Monday, for those of you that were out on Monday. Any questions about where the numbers and the parentheses and where all that's coming from? Do I have any numbers I can plug in right now? I know I have 5 triangles. And the triangles is 1/2 base times height. Do I have the base or the height of the triangle right now? I have one of them. I have the base. What's the base of the triangle? 12. Good. So I have the base, but I need to find the height. Do you agree? Now, it's not the height of the whole pyramid. It's just the height of the triangle. Anybody remember what we did last class to do that? I'm going to use SOHCAHTOA. Good job, Cynthia. Okay. I need to draw this little right triangle down here. And we're trying to find the height. Where did the 6 come from? Half of the bottom. I'm basically just kind of drawing in this guy over here, right? I'm just trying to find the height. I can't use Pythagorean theorem because I don't know what the radius is. Do you agree? I don't know that hypotenuse. But I can use, Cynthia said, SOHCAHTOA. I can use trig because I can find one of the angles. So, if you remember how we did it last class, I said we could find that angle. Do you remember that? How do I find that angle? Look at the picture. We know that all of these angles should add up to 360. How do I find that guy? Well, I'm going to divide it by something. It's regular, so I can divide it. 360 divided by? It's 36. How'd you get that, Abdul? Yeah. 360 divided by 5 gives me 72. And that's just one of these angles right here. Do you agree? The whole thing? But the way in my right triangle, it's half of that. So half of 72 is 36. Any questions? Emily, you okay with where the 36 came from? I know, here, come back to me. Are we okay with 72? It's 360 because all these angles in here divided by 5, because there's 5 sides. And that gives me 72, but in my right triangle, because I want to be able to find the height, I got to use trig, so I'm going to divide it in half by 2. That's where the 36 came from. All right, so now, Cynthia says we got to use trig. Which one? Sine, cosine, or tangent? It is tangent. Very good. Looking at my angle, we have opposite and adjacent. That's TOA, tangent. So it's the tangent of 36 is equal to, and I have to write a fraction on the other side. What is that? What fraction is it? 6 over x. Good. Gosh, the x is on the bottom. That's just a 2-step process to solve for x, right? I got to multiply both sides by x. And then I have to divide by the tan of 36. So what is 6 divided by the tangent of 36? Let's do 8.26. 8.3 is a little bit rounded. 2 decimal places is usually a good rule of thumb. That way we don't round our final answer doesn't get off too much. Okay? So what is that? That's a lot of work to find what? The height of the triangle, right? So we're scrolling back up. In other words, this number goes here. We're just still trying to find the area of the base. Do you agree? We're still on that. We're not even at the surface area of the whole darn thing yet. So 8.26 goes here. So what is that area of the base? Now we're going to multiply it all. We have 5 of those triangles, 1/2 base times height. I think it's bigger than that. Oh, 247. I'm sorry, yes. So that's correct, 247.8. Did you get that? That looks right to me. We'll worry about units at the end. Double check that you got that, though. Good. All right, so that's not my final answer yet. That's just the area of the bottom of the pyramid. Now I have to go back up, scrolling back up, and I have to plug it in here. So I have 1080, which was the lateral area, plus the bottom pentagon. So the surface area in total was 1,327.8. And we do need to worry about units here. I think it was feet, wasn't it? So it's surface area, so it's still square feet. That was a big problem. How do we feel about it? It's a lot. I agree. The area of the base is the hardest part in these kinds of problems. But they're not always pentagons. Sometimes they're squares. That's nice. Sometimes they're circles. Sometimes they're squares, triangles. They could be lots of things. But I wanted to do a difficult example so you had one to follow, okay? Okay. How do we feel? One more example. We've done lateral area, surface area. What do you think's next? Volume. But I'd like to do a different one. Let's do a volume of a basketball. This is a funny story to me. Well, I didn't erase it, so don't look at anything. Okay, good. I didn't erase it. Sorry. Don't look at anything. Okay, good. My son got a basketball hoop several years ago for Christmas, and I, being the lazy mom that I am, I ordered the basketball on Amazon because I didn't want to go to like Walmart and get it or Dick's or anything. So do you know how they send basketballs on Amazon? Flat, no air, because they don't want the ball rolling around. And guess who didn't have an air pump? That'd be Mom. Anyway, so I learned all about needles and what you have to do to blow up a basketball. But why is that example a volume problem? My flat basketball. Fill it up with less space, right? So the box is going to have less space. So they're maximizing their weight, and Amazon was doing a good job with that. But for volume, I had to fill up the basketball, right, with air. How much air will it hold? All good questions. Okay, so example 2. This is actually our last example. Kind of nice. I only want you to draw or write, you can draw the picture, the basketball, and then what's highlighted, okay? A basketball has a circumference of 30 inches. And we're just going to find the volume. Okay? Just going to find the volume. What is the volume? For my groups from the beginning of class today, my sphere people, what was the one variable you needed? Radius. I am not given the radius. I need to find it. Find the sphere formulas on your formula sheet. Look for the sphere. Do you see that the only variable you need is r? We already know pi, and then we know 4/3 and 4. We know the numbers. We just need r. But I'm not given r. I have to find it. What are we given? Circumference. Do I have a formula for circumference? What is it? It's on your formula sheet too. 2 pi r. Very good. So I know that 2 pi r is equal to 30. Do you agree with that? That's the circumference. How do I solve that for r? Because I know I need to find r. How do I solve that equation for r? Divide by 2 pi. Very good. So r is equal to 30 divided by 2 pi. So we have to be very careful about how you type this into your calculator, because this is the most common mistake that I see. The most common mistake that I see, if I can get my calculator to turn on, there we go, is this, 30 divided by 2 pi. And that is incorrect. Because the calculator does order of operations. It's only going to divide by 2 and then multiply by pi. So in other words, if you wanted to do it this way, you would have to insert parentheses. Now, how many of us are going to remember to do that? Probably a few of us, right? So instead of doing it like this, I want you to get into the habit of, if you see a fraction, use the fraction on your calculator. Where is that, by the way? Good. So alpha y equals. Just get into that habit so you don't have to worry. You don't have to worry about the parentheses part, okay? So 30, and then on the denominator, we have 2 pi. So 30 divided by 2 pi is 4.77. Okay, so it's very important that you use your fraction there, or parentheses. So 4.77 is the radius. Great, that's what I needed, didn't I? So what's the formula for volume of a sphere? Look at your formula sheet. What do you see? So 4/3. Keep going, Carlo. Pi r cubed. We have to be careful. Do we know where the cubed button is on our calculator? I hope so. We'll find it. We'll do it together. So we have 4/3 pi, and then what am I plugging in for r again? We just found it. Yeah, 4.77. Okay, so I found my radius, and now I'm going to plug it in. So if you're not sure how to do the cubed function on your calculator, watch how I type it in, okay? I'm still going to do my fraction, alpha y equals for 4/3. I have to be careful now because if I keep typing right now, it'll stay in the bottom of my fraction. So I'm just going to use my right arrow key to get out of my fraction. And I'm going to type pi. And then I'm going to put parentheses 4.77. And now I have to tell the calculator to the third power, cube it. So I'm going to use the little caret up arrow that moves it up into the exponent, and you type 3. Okay, that's just how you type at the cube. Now, notice that my little cursor is still up in the parentheses. If I had more things to type in, I would have to use my right arrow to get it to come back down. Okay? And that's it. So the answer is 464.6. Now, what are my units? What do those two little lines mean? Inches. So it's inches cubed. So make sure that so volume, whatever the unit is to the third power. Okay? Excellent. So we did a lot today. We took a little quiz on polygons. We divided into groups, and we did shape sorting. So you don't have time to do all of these problems today. I know that. So what I want you to work on is writing the formulas down. If you want to take a picture of that formula sheet, go ahead. You can actually Google it if you want. It's just a SOL formula sheet for Virginia geometry, you know. It will work, that's fine. But it's a good idea to write the formulas down today. All these 9 problems, and there's only 9 of them, will be due at the end of class on Friday. Okay? So we'll have some time in class on Friday to work on it. Class.